This video gives a short introduction to modeling thermal zones in Revit for Sefaira analysis. First, a quick explanation of thermal zones. Heat gains and losses are not uniformly distributed within a building or even within a single floor plate. South-facing zones will have more gain than north-facing, and office spaces will have more internal loads than a residence. We create zones to more accurately capture this uneven distribution of heat in a building. There are three types of zoning available in Sefaira's web application, which you see here. They are available under the Zoning tab. The first type of zoning is one zone per floor, where each floor is its own zone. This is currently the default zoning in the plugin and is useful for large-scale massing comparisons when the interior layout of the building isn't known. The next type of zoning is perimeter core zoning. This is a good approximation for most early stage analysis when design is still evolving and the layout is still being informed. You can see that perimeter core zoning works by offsetting a zone a certain distance from the exterior perimeter of the building. There's a default for that, which of course you can modify if you like. You'll notice that Sefaira also has something called detailed perimeter core zoning. What's the difference between basic and detailed? Well, essentially in basic perimeter core zoning, you'll notice that all zones that face the same orientation are essentially the same zone. All three of these north-facing zones are P01. These two west-facing are P04. If I change that to detailed perimeter core zoning, you'll see that each zone is assigned its own number. They are all modeled as separate zones. And in a case like this, where you have a building that has fairly significant self-shading, you may want to use detailed zoning to account for that impact. Do keep in mind, though, that the more zones that you add to a model, the slower the analysis will run. The final type of zoning is one zone per room. This is the most specific and the most accurate type of analysis. Also allows for the most flexibility. In this case, it's pulling rooms that we've modeled in our Revit model. And we can see those rooms visualized here. Room by room zoning isn't always necessary, but it can be useful if you're doing zone level HVAC equipment sizing or very detailed thermal comfort studies. So let's move over to Revit now and look at best practice for defining these zones in Revit. Here's the Revit model of that building we were just looking at in the Sefaira web application. I'm going to go ahead and look at a floor plan view so I can see the room layout. And you'll see that rooms have already been defined here, and these are the rooms that were picked up and read in the Sefaira web application. A couple notes. One is that you have to use rooms. You cannot use spaces or zones. Those will not be read by Sefaira. One other thing to note is that any area that is not within a room will not be imported into the web application if you use room by room zoning. So what that means is that you should make sure all conditioned area is included in a room. Typically what we'll see is maybe a small janitor's closet or some other interstitial spaces are not given a room assignment and therefore are not read into Sefaira, and the total floor area may not match what you expect. One final note is that the room by room name is a bit of a misnomer. Zones are not necessarily equivalent to rooms. As I discussed at the top of this video, you can aggregate rooms with similar loads, and you probably want to do that because, as I mentioned, analysis time increases with each additional zone. So modeling every single room as a separate zone will slow analysis down considerably. Here we have one example. Let's say that this is perhaps a classroom building and we have a number of classrooms, similar use on a similar orientation. Instead of modeling each of these as a separate room, we could group these together into one zone. Now the way that we would do that in Revit, let me just go ahead and remove one of these rooms here. The way that you would do that is by making sure that the rooms that separate, the walls that separate those rooms are non-room bounding. So if we come over to the Properties panel, you can see there's a room bounding checkbox. and apply, now this room, number 17, has extended into that space. So I can continue to do that across these other walls in this area and create a set of zones that more closely align with the loads that this building is experiencing. Again, the general rule is that you can group spaces that have similar occupancy and similar internal loads and similar external loads. So that's it. Once we have the rooms the way that we like that, we can go ahead and upload this model to the web application and use our custom zones.